Hi students, in this session let us learn what is logarithmic amplifier, how to analyze this logarithmic amplifier. So here what is logarithmic amplifier means, here the output is proportional to the logarithm of input. For this circuit, what is the output? Output is V out is proportional to logarithm of what is input here? Input is I in. Okay, we have to prove this relationship between output voltage and input current. Okay, now let us assume the potential at inverting terminal is V minus, potential at non-inverting terminal is V plus. So according to virtual ground concept, okay, potential at inverting terminal is equal to potential at non-inverting terminal, where non-inverting terminal is grounded. It means you have to take V plus equals to 0. Okay, so according to virtual ground concept, V minus equals to V plus equals to 0 for this circuit. Now let us assume the current flow into the inverting terminal is I minus, current flow through this diode is ID1. So here what is the current flow here? It is I in. Okay, now consider a node V minus. Consider a node V minus. So at V minus, what will happening? The current I in is flowing towards the node V minus, and I minus and ID1 is moving away from the node. So that you can write it as I in equals to I minus plus ID1. Okay, but due to high input impedance, of op amp, Ri is infinite, ideally I minus equal to I plus equal to 0. Okay, now substitute this in above equation, then we get I in equals to 0 plus ID1, which means that I in equals to ID1. This states that whatever the current you are applying as a input to the circuit is the same current is flowing. The entire current is flowing into the diode D1. Okay, there is no current flow into the operational amplifier or a inverting terminal. Okay, now we have to determine the voltage drop across the diode, which can be considered as VD1, which is nothing but, for this circuit VD1 is nothing but, VD1 here it is potential between the diode or voltage across the diode, which is VD1 is nothing but V minus minus V out. So you can write it as V minus of V out. Okay, but according to virtual ground concept, V plus equal to 0, so that V plus equals to V minus equal to 0. So therefore VD1 equals to 0 minus V out, which is equivalent to VD1 equals to minus V out. Okay, this is one more relation. But we know the current flow in a diode is equals to reverse saturation current into exponential of voltage across the diode VD1 by Vt minus 1. So here Vt is nothing but Kt by Q, which is equivalent to 26 millivolts. And here, where e power Vd1 by Vt is much greater than 1. So you can write it as Id1 equals to Is, reverse saturation current, which is approximately equivalent to e power Vd1 by Vt. Okay, but already we determined what is Vd1. Vd1 equals to minus Vout. So now you can write it as Id1 equals to Is e power minus Vout by Vt. Okay, but here it is a logarithmic amplifier. We have to prove that the output voltage is proportional to the logarithmic of input current for this circuit, so that we also know the relationship between the Id1 and In. So here In equals to Id1. So you can write it as Id1 is equals to In equals to Is e power minus Vout. Now here we are having a relationship between In and Vout, but it is exponentially. But due to this logarithmic amplifier, you have to convert this exponential into logarithmic. So for that, what you have to do? You have to convert this exponential into corresponding logarithmic. I can write like this: In by Is. So minus Vout by Vt equals to ln of In by Is. Okay, now what will happen? You have to determine Vout equals to minus Vt ln of In by Is. Okay, so here Vt is constant 26 millivolts, and here reverse saturation current Is, and In is the input current what you are applying to the circuit. And finally you have to determine the output voltage for the logarithmic circuit. The main advantage of the logarithmic amplifier, or main applications of the logarithmic amplifier, is which can converts wide range of values into smaller range. So this is the major advantage. At the same time, applications in wherever you want to convert wide range of values into smaller values, there we have to use a logarithmic amplifier. So this is about the logarithmic amplifier, how to determine the respective output for the logarithmic amplifier. This is the analysis of the circuit, and this is the relationship between the output voltage with respect to input current. If my explanation is helpful for you, please like, share and subscribe for more videos. Thank you.